Hi, I'm Kevin from Hutson Engineering Services. Today we're going to talk about a very special project that we've just recently started. It's for an AM V8 and it's the V600 Le Mans. So that's a super rare version of the 550 Vantage with only 40 examples made. Now, this engine's come into us with the client reporting that the liners were weeping through the telltale holes. So we have, for those of you that follow the videos, we have discussed the cylinder liners before and the corrosion and things that go on at the bottom of the liners in the earlier blocks. Now this is a later engine. This is the multi-valve engine with the 4 valves per cylinder heads. With it being the 550 engine, we have the big twin Eaton superchargers as well. Now to get the horsepower from 550 to 600, they put a smaller pulley on the front to up the rate of the supercharger, and some other small modifications as well. So this is the cylinder block. We've removed the cylinder heads. We've also removed the cylinder liners. The weep holes along the side here are exactly the same as the earlier V8, and they have the same issues in relation to the liners leaking. So the water, the coolant was running out of these holes, and somebody has, there's actually silicone just pressed over the top there in an effort to try and cure the problem, but that doesn't work, not even short term. So with the liners removed, what we've noted in the past with the Vantage engine, the 550, and also a 1 or 2 coupes, is the liner O-rings, which are these rubber seals here, they degrade, they go hard and they lose the elasticity, and that elasticity is needed to perform the appropriate seal between the liner spigot at the bottom and the cylinder block. Now what happens is, with the earlier engines, you tend to get just a little bit of a weep because of the usually excessive corrosion down there as well. But with this later engine, when these start to fail, the coolant that passes through these little holes here is actually quite substantial. So we go from having a very small weep to actually a puddle forming underneath the car, where the weight of the water is pushed through this little tiny hole. So what happens is the coolant surrounds the liner, and it's this seal here that usually breaches. It goes into this cavity, follows the cavity round and through the hole here, and that's where we usually come in to carry out the repair. Now with this engine, what we was intending to do is actually remove the cylinder, strip the engine down, remove the cylinder heads. We strip the cylinder heads. We'll show you those a little bit further on in the video, but the intention was to dismantle the engine, to process the parts and clean them, and to rebuild it using the original liners, but just changing the liner seals and some wear parts within the engine. So that would be, we would change, as a matter of course, we would change the main bearings, the big end bearings. We would also change the timing chains. The cylinder heads, while we have them off, would always benefit from being dismantled, and would change the valve stem oil seals. We would then completely clean the block up, all back to fresh, clean surfaces, new liner seals on, insert the liners, pressure test, and then we would rebuild the engine and with minimal work really. Now the issue that we found here, which was quite surprising because the car was running quite well, is that when we've removed the crankshaft, The main bearings all look to be in good order. The big end bearings are in good order. It's been really looked after, this car. Everything is clean, and as you would expect from a relatively new vehicle in terms of the Aston world, with a lot of the earlier engines that we see. With the modern castings and the modern materials, they tend to not suffer corrosion as of yet. So we was quite surprised to see some issues relating to the crankshaft. Now, the cylinder block is a 5 main cylinder block, and the centre bearing here houses what we call a thrust bearing. Now, the thrust bearing, it governs the movement of the crankshaft from side to side. Those thrust bearings were completely destroyed. They're a steel bearing with a surface bearing layer on. That had been completely removed. It had broken up, and it had caused some issues with the crank. For whatever reason, the lubrication has been removed from this bearing, so we've had metal on metal, which has obviously had the catastrophic effect on these bearings and the crank also, which I'll move on to in a minute. Now, in the V8 engine, these bearings sit in the block fore and aft. For the 6-cylinder engine, you have the same bearings, similar bearings in the block, but you also have the bearing in the main cap as well. So it actually looks like this. So you get a full 360 degree bearing rather than just the 180 degree that you see on the V8. They are thicker, so they have been compensated. But what's potentially happened here is the clutch adjustment might not have been correct, or it's been the clutch pressure has just been too much, pushing against that. Now, with the engines producing 600 foot-pounds of torque, 600 horsepower, that clutch has to enable the horsepower to be transmitted through the drivetrain and eventually to the back wheels. Now, that clutch, that point of connection between the engine and the gearbox, the clutch has to be sufficiently strong enough to be able to overcome that torque. Now, that pressure is obviously, it can be quite sufficient, and it's been, we think, been pushing on the thrust area here, and it's just been too much for the thrust bearings to cope with. So what we do is we'll probably do another video later on of what we're going to do to improve this. There's some machining we can do, and we can manufacture some thrust bearings out of a different material that would stand up to a little bit more abuse. But the main issue that we found is with the crankshaft. The bearings breaking up themselves. There's no damage to the block. The main bearings weren't in any considerable poor state. They're just what we would class as normal wear. But the heat and the build-up that has been caused from this bearing failure has been transmitted directly into the crankshaft. Now, what that's caused is on the thrust face here of the crank, this is where the centre, this is where these bearings would run, either side, and that would govern the movement fore and aft. Now, that heat has been transmitted into the crankshaft, and what we can see is a number of cracks in the crank. The cracks go all the way around the thrust face. There is a radius from the main bearing to the thrust face. Now that radius is vitally important for strength. So if that radius is breached with a crack, that and things start moving, that ends up being a weak point, a fracture point, and it'll eventually, the crankshaft will actually end up snapping, breaking in two. So with the cracks in the thrust face, which we really wasn't expecting to see. With these engines, and the vehicle that it's in, it looks like it's had a very, we thought it had a very easy life. They're very cosseted vehicles because of the rarity. So this type of failure was, actually quite a big surprise for us. So we're going to have to look at resolving that, and we're going to try a couple of other things first. We're going to carry out some further tests. So the initial test that we did, we could see some potential areas of the crank that could be cracked. So these are very easy method of just as an initial test. If it passes from this point, we would carry out what's called magnaflux testing. The magnaflux testing is where the crank is sat in on some V-blocks like it is now, and there's a solution that's passed over the crank. The solution holds particles. Those particles are very, very small, and you pass a current through the crankshaft. It's a big machine called a magnaflux tester. You put the foot on the pedal, and the current that's going through the crankshaft draws these particles into any cracks, and then you shine, you close the curtain and you put an ultraviolet light on, and these cracks, these particles show up as being bright green or bright yellow, depending on what type of particles you use, and that's a more thorough test. But as an initial test, the dye penetrant on this showed up the cracks on the crankshaft straight away, which is really unfortunate. We will have a look at potentially, we might grind the crank just to see how deep they go, maybe possibly just out of interest, but my concern is if those cracks are deeper, with the flexing of the crank, it would break, especially the sort of horsepower that's going through there. The next stage could be to have this x-rayed and analysed that way, but for peace of mind, having spoke with the client, what we will be doing is we'll be having a new crankshaft manufactured, and this will be a direct replacement for this, and then we can rebuild the engine with some modifications on the thrust, just to beef things up, and hopefully we'll have this engine back running again and performing as it should do with the new components. If you have any issues with your 550 Vantage or AM V8, please give us a call. We'd be happy to discuss the options available, and also give any advice should you wish, should you need it.